Hi, I'm Lena, and I'm going to take you through some professional development around place value today. I chose this opening picture because it's a representation that one of my young people made in class just last week about or of 4 groups of 23. And while it's not directly related to place value, I think it's a really good illustration of the gaps that some of our young people have in mathematics and how we need to move to fill them if they're going to be numerate citizens. Before we get stuck into it though, I'd love for you to think just for 30 seconds, you can take some notes if you want, about these 3 questions. And I would love also for you to turn to the person next to you and just discuss what you wrote down or what you thought about. And can I get 2 people to share on each of these questions, please? Great. Thank you so much for sharing. That gives us a really good sense of where we're at and a really good launching pad to keep going. This is just a bit of an agenda, so you know where we're at through the course of the presentation. I'm going to go through the purpose of the professional learning, so you know exactly what you are going to get out of it. We're going to look a little bit at the background, so what you need to know before we get stuck into place value for teaching. Then we'll be looking at what kinds of things you need to understand in place value in order to teach it well, some ideas for teaching it, and then there'll be a chance for you to have a go. And lastly, I'll sum up. You can give some feedback and ask questions if you have them. So the purpose of this professional learning is to improve what's called pedagogical content knowledge, and I'll go into that next, for the teaching of place value. Our success criteria is that I hope you will have a deeper knowledge of how to teach place value, and that you'll be able to implement a learning from this session into your classroom, not only next week, but regularly. I've chosen place value because across the literature, but specifically in HeartNet, or in HeartNet's work, it's said that it's a really complex area and it's actually quite common for teachers to have gaps. And I know that a lot of us have gaps, especially in maths, because there's not many of us who are specifically maths trained, and we're coming from secondary backgrounds with specialist areas that aren't maths, and we're being asked to teach primary level mathematics. And the other thing that's really important is that it's place value, and understanding place value is fundamental for young person development in mathematics. And a lot of our young people, as we know, are coming to us with lots of gaps in their education. And if they don't have this foundation in place value, they'll really struggle to move forward. And I love this quote from Simon in 2007. It's very dramatic, but it really goes to represent how important place value is. It says, one of the main aims of school mathematics is to create mental objects in the mind's eye of children, which can be manipulated flexibly with understanding and confidence. A prolonged reliance on inefficient strategies, such as make all count all, or counting by ones, is both developmentally dangerous and professionally irresponsible. We're going to talk a little bit more about counting by ones later, but I think you've seen young people in your classroom counting on their fingers, counting by ones. And it's a really sure sign that they need some intervention in place value. I'm hoping that I've structured this professional learning well. It's based on the writing of Darlingham and Tyler and Gardner, who say that the best professional learning is content focused. So we're really honing in on place value, that it incorporates active learning, so you get a chance to try things, supports collaborative learnings. I'm hoping to give you opportunities to talk, and of course, using models of effective practice. I haven't taken what's in this presentation out of my own classroom. I've taken it from peer-reviewed literature and really experts in the field. A little bit of background first though. So what's really helped me with understanding what I need to know to teach maths well is this idea of the domains of mathematical knowledge for teaching. And I think it's just like a huge breath of fresh air, because it recognizes all the different areas you need to have knowledge in to teach well. So for example, I've kind of like reframed it as a soccer pitch because I know we love sport here. But like on the left-hand side there, I think is some areas that we're really strong in. So we've got common content knowledge, which is maths that everyone knows, like regardless of whether they're teachers or not. Then we've got specialized content knowledge, which is knowledge of maths that you would know only if you were a teacher, for example, like things like Year 9 maths or specialist maths. Then we've got horizon content knowledge, which is like being able to look into the future of what kids need to know next. And I think we've got some of these things down pat, especially because we're coming from secondary backgrounds and we're pretty numerate ourselves. So I know that you all know how to manipulate place value. What I think we need a bit of support in is looking at knowledge of content and students. So not only what is the content, but how does it interact with our students, and how do we make sure that they don't have misconceptions, or how are we addressing their misconceptions? The next one, knowledge of content and curriculum. So not just knowing what to teach, but where it falls in the curriculum, what the sequencing is in the curriculum, things like that. Finally, knowledge of content and teaching. So again, not just what is the content, but how do we best teach it? I'm hoping to address these today because I think these are the areas where, like on the left-hand side, I feel like we're really playing really well. Our conditions are great, we're scoring goals. On the right-hand side, I feel like we're running out of breath. The sun's in our eyes, the wind's all wrong, and hopefully we'll come out of today with a bit more knowledge in these areas. So firstly, these curriculum connections. To place value is developed in the primary levels like this. We're starting by counting, so learning to count in foundation, counting by ones, and then going through the levels, we're skip counting, so 2s, 5s, 10s. Then we're going into like partitioning, rearranging, and regrouping. So that's things like knowing that 30 contains 3 groups of 10 and 1, or it's 31 ones. So just understanding these parts of place value. And then we're going all the way to, say, Year 6, where we're into decimals. So looking at smaller units in place value. One thing that really helped me to understand how complex place value is this idea of Rogers, that it's actually got 6 aspects to it. So it's not just naming numbers and counting, but it's also making and representing them with materials. It's comparing and ordering them. So knowing that when something shifts in the 10s up or down, that number gets bigger. But if something's shifting in the 1s, it might not get as big as something that's shifting in the 10s by 1 unit in that section. It's renaming as well. So like I was saying before, knowing that 31 is 31 ones or 3 10s and 1 1, and then it's calculating too. So using a knowledge of place value to help with calculations. And I love this quote from Rogers as well. She says, as a teacher, I could see that place value was like the frame of a house. It held everything up. And again, it just really goes to show how important place value is, especially for young people that have gaps in education. If we address place value as a foundational gap, we'll hope to see improvements in maths outcomes. So Booker, Bond, Sparrow, and Swan give a really good sequence for teaching place value. So they say that it starts by linking number names, symbols, and materials. So they say lots of children know how to count, but they're often missing the link between the names that they're saying, the symbols, so like 30 for 30, and the materials, so that 30 looks like 10 bundles of paddle pop sticks, or sorry, 3 bundles of 10 paddle pop sticks. Then they say to develop thinking in 10s, and they really hone in on the focus of they really hone in on the concept of 10. They talk about establishing place value in these 2-digit numbers, so that being really important, and then extending into 3-digit numbers and beyond, so into 4-digit numbers, thousands, etc. They also say that you can extend this in a similar way to decimals. So you can teach decimals in the same way you teach 2-digit, 3-digit numbers of place value. Decimals also talk to that base 10 number system. 1 is divided into 10 parts, just the way that 10 is divided into 10 parts. And we talk about tenths and hundredths, so it's very replicable. They identify 2 really important misconceptions for young people, and I think lots of our young people have these. So missing the concept of 10, and we can see that when young people count on by ones, so they go 8, 9, 10, and they keep going 11, 12. And for example, if they're doing something like 8 plus 4, they go that sort of laborious route of 8, 9, 10, 11, 12, okay, rather than thinking, well, 8 is 2 away from 10, and then add another 2 is 12, that kind of thing. Another misconception is that 0 is nothing. So 0 just being a placeholder, but it's not. 0 is not a placeholder. It actually means that there's none of that place. It's actually really got significant meaning. So in this situation, they suggest to focus on the link between number names and symbols and what 0 signifies in that symbol. So for example, in 30, we've got the symbol 30, and actually the 0 signifies 0 ones. So really honing in on that. This video is really enlightening. It's Joe Bowler talking about that misconception of counting on.
So there are very few research studies, very, very few, that I have read and immediately thought the results were so powerful they needed to be blasted from the rooftops and everybody should know about them. But here's one. 2 British professors, Eddie Gray and David Toole, worked with 72 students between the ages of 7 and 13, and they had asked teachers to nominate students they thought of as above average, average, and below average. They then gave the students various addition and subtraction problems to do, and they categorized their strategies. For example, they gave them problems such as 7 plus 18, which is the addition of a single-digit number to a teen-digit number, as you can see here. And what they found was that students used 4 different strategies when they worked on number problems. So the strategies were, some students counted all. So with 7 plus 18, they would say 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, and count up to 18. And then to add them, they would count them all again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and go on like that. The slightly more sophisticated strategy of counting on is when students would add up to 7 or to 18 and then continue on. So if they'd added 18, they would then say 19, 20, 21. Known facts was when students just knew what the number bonds, they just remembered them. And what they called derived facts, which I would call number sense, and which this whole session is about, was when students were able to break numbers apart and decompose and add them and use them flexibly. So for example, they might say with 8 plus 17, I'm going to take 8 plus 2 and make that into 10. Or they may break 17 into 15 plus 2 and then calculate 15 and 2 and 8. So they make the problems into easier addition problems. And the results from the 8-year-olds was stunning to me. So the above average students, 30% of them knew the numbers, they used facts, known facts. 61% of them used number sense, so they used the numbers flexibly. And 9% of them counted on. In the below average group, 6% of them used known facts, none of them used number sense. 72% of them counted on, and 22% counted all.
So she goes on, it's so interesting. She goes on to talk about how these below average children, which are really our young people that we have at school, are learning harder maths. Like they're learning totally different maths, and it's more difficult, and that's why they're getting stuck. And so I think, again, it's really important to focus in on place value and teach them these things that can move them forward more quickly in maths and make maths easier for them. So now moving on to our strategies. So thinking about games and how we use them so much in our engagement of young people at this school. And I think games are a perfect way of teaching place value as well. It's naturally engaging. It's much less intimidating than sort of, these kind of direct instruction models that can really put kids on the spot, especially when they're working through things that they feel are like babyish. Booker, Bond, Sparrow, and Swan also say that they're a great opportunity for teachers to observe. So teachers can take a step back. It's really student driven, and teachers can really observe who's where. And also feedback comes immediately from peers in games, which is really helpful. So there's this real like bang for your buck. We know as well from Vygotsky that the influence of play on a child's development is enormous. So we know that play is a really important part of developing, and why not develop place value through play? There's a few game ideas there that Booker, Bond, Sparrow, and Swan give. They're very, very simple. For example, that top one, make 10 or make 100, is just using a 10-sided dice. Young people work in pairs or in groups to build numbers into those carriages that are on the screen. So if you say roll a 6, you'd colour in 6. The next time when you say roll a 6, you can see really when you go over the boundary of 10, which is really helpful. Same thing goes for a structure that has 100. There's a different game that we'll play at the end, which is 10s and 1s, or 100s, 10s and 1s. We're going to play make 100 at the end, but 10s and 1s, or 100s, 10s and 1s, is where you pick a number, for example, 162, and young people will take it in turns to roll. So in the 100s, 10s and 1s version, they'll roll 2 die, and again they'll colour in where they're up to on a template. And once they get to that, or the first person to get to that number wins. If you're playing with lots of different groups, you can say, well, whoever gets to that number or above wins. And also we're going to order those winning numbers from highest to lowest. Another good one is go fish. So looking at the concept of 10 and numbers that pair up to make 10, so like 6 and 4, 7 and 3, 5 and 5. You can play with the picture cards in a normal pack as well. Picture cards can just be 10, or you can agree on what their value is. And young people play in a group, they're dealt out cards and they need to make pairs that equal 10, and they can take from other people. So for example, if I have a few cards in front of me and one of them 6, I might say, Liam, do you have a 4? If Liam has a 4, he has to give it to me, and then I get a pair and I put it down. If he doesn't, he says go fish, and it's the next person's turn, and the person with the most pairs wins. There's heaps of other suggestions in Booker, Bond, Sparrow, and Swan. I'll talk about the cup idea in a second, but you've got the classic ordering one, so giving each young person a number and getting them to stand in order, or giving out heaps of numbers and getting them to pin them on string. Using those 10 frames that are like those little train carriages in the previous slides, are really seeing where the concept of 10 stops and starts. And then using these number expanders that help kids to see that like 348 is the same as 34 10s and 8 1s, or 348 1s. I'll show you this cup activity now. So this is from Rogers. She uses the words in there, and you can actually stretch out those cups, and she's written how to read them on there. Or there's this other version which is on YouTube. I'll just play like the first 30 seconds just to show you how it works. So they're using the colours for the periods, like millions and thousands, just to give young people the cue for how to read. And Roger's actually, in her example, this one here says that kids who can't actually count to 1,000,000 can still read really, really big numbers, which gives them a lot of excitement. And in that sense, that's really like a really good way of teaching place value. So now you get a chance to choose whether you want to play the Make 100 game with the 10-sided dice, or if you want to work on this worded problem. I'll give you a moment to choose and organise yourselves, and then you'll have a few minutes to play or to work out the problem. Just have a go, put yourself in the young people's shoes. And finally, these are our key takeaways. They're going to be on your resource, but place value is absolutely fundamental. Lots of young people have gaps and we need to fill them so that young people can build on it and get better at their maths. The best way to teach it is to link materials, so manipulatives, with the language and the symbols. And again, using games just makes it more engaging, less intimidating, and is really effective. Just as we close, this is on your resource as well, but have a think about 3 things you've learned, 2 things you can use in your classroom, 1 question you still have. And if there's any questions you'd like to ask the group, now would be the time. And my last slide is just references.